and today's lesson is on stoichiometry of gases.
So hello everyone, today's video is the stoichiometry of gases, our last brief topic in this stoichiometry unit. Until now we've been stuck at 22.4 liters of gas per mole at STP. We haven't really had a way to deal with different temperatures and different pressures. So let's look for example at our recent eudiometry lab, where we reacted calcium carbonate and hydrochloric acid releasing some carbon dioxide gas. Here we have the eudiometer in its water bath. The carbon dioxide gas was collected in the top there, and here's the flask that had the calcium carbonate and the syringe that we injected the hydrochloric acid in. So here we have this reaction, it's balanced, and the carbon dioxide gas being released. Now we measured the volume of the gas, and we used the molar volume of a gas at this temperature and pressure, which was not at STP. Another way of doing this lab, if we hadn't been able to deal with the not at STP volume of the gas, we could have measured the mass escaping in open systems. The whole thing could have been done on a digital balance, and we could have measured the mass escaping as the reaction proceeded. Anyway, let's lose no time and zoom in on our eudiometer here. Here's a closer look at it. The water levels are shown and the gas being collected up in the top here. Now we need to be aware of a few things when collecting a gas over a liquid, such as we were doing in eudiometry. The first idea is this one. Carbon dioxide is not the only gas in the eudiometer. Of course, we had the air that we displaced by adding our 10 milliliter sample of hydrochloric acid. And also, of course, we had the water vapor that was coming off of the top of that column of water. And the question is, of course, how much is that? It also may not be 1 atmosphere pressure inside the eudiometer. As it's drawn actually in the graphic here, the pressure is less than 1 atmosphere pressure. So here is a situation where you have two eudiometers in the same water bath at two different levels inside. And you can see the eudiometer on the left, the pressure would actually be less than atmospheric pressure, and the one on the right, the pressure inside would be greater. This can be resolved by submerging the eudiometer to a point where the levels inside and outside are equal. So let's just redraw that last set of two eudiometers there, and we'll submerge them to such a degree that the water levels on the inside and outside are equal. So move the left one down and the right one up. And now the pressure level inside and outside will be equal. So one thing with eudiometry, if possible, measure the volumes of a gas where the outside and inside water levels are the same. Even so, we're still stuck needing the molar volume at this temperature. So how do we get that molar volume? Well, if you might remember our brief introduction to ideal gases, that was last class, but don't worry, if not, we'll go into the next class in great detail. The idea was the pressure would be proportional to the number of moles of particles and the temperature and inversely proportional to the volume, or P is equal to nRT over V, where R is the ideal gas constant. We'll solve this for the volume of a gas at our conditions, which were 1 atmosphere pressure and 23 Celsius if you recall. So we'll solve V is equal to nRT over P and get the rest of our values in here and work out what the molar volume of a gas was at 1 atmosphere pressure and at 23 degrees Celsius, which is where we were when we were doing the lab in eudiometry. So here we have the molar volume, V is equal to nRT over P. Putting in all the numbers here, checking the units, they come out as liters. And it turns out that the molar volume at 23 degrees Celsius and 1 atmosphere was 24.3 liters per mole. So we use this volume rather than 22.4 when doing the gas stoichiometry. Anyway, those are a few considerations when doing the stoichiometry, including gases, and to have fun calculating yields. And we'll see you soon, everybody. Be sure that you stay tuned for our next lesson, lesson number 21, the introduction to gas behavior and the ideal gas law.
This is my dad's YouTube channel. It's awesome. So like, comment, and subscribe.